Students, it is very easy to solve linear equation in one variable. Example, the sum of two numbers is 100 and their difference is 20. Solution, assume two numbers are x, y. According to the condition given, x plus y is equal to 100 and x minus y is equal to 20. Add these two equations, we get 2x is equal to 120. Therefore, x is equal to 120 upon 2, that is, x is equal to 60. Substituting x is equal to 60 in equation 1, we get 60 plus y is equal to 100. Therefore, y is equal to 100 minus 60 is equal to 40. Therefore, x is equal to 60 and y is equal to 40. Let us see what is meant by quadratic equation. Quadratic equation contains quadratic polynomial. We have studied quadratic polynomial and zeros of this polynomial. We will revise it. Zeros of a quadratic polynomial. The general form of a quadratic polynomial is ax square plus bx plus c, where a, b, c are real numbers and a is not equal to 0. Consider a polynomial. P of x is equal to x square plus 5x plus 6. For different values of x, which is a real number, we get values of p of x. We find that for x is equal to minus 2 and x is equal to minus 3, the value of the polynomial p of x is 0. So, minus 2 and minus 3 are called zeros of the quadratic polynomial. In fact, every quadratic polynomial has at most two zeros. How do we determine required zeros of a quadratic polynomial? Zeros of quadratic polynomial can be obtained by equating quadratic polynomial to 0, that is, ax square plus bx plus c is equal to 0, and solve the equation. This is a quadratic equation. Let us look at the standard form of the quadratic equation. The equation of the form ax square plus bx plus c is equal to 0, where a, b, c are real numbers and a is not equal to 0 is called quadratic equation in variable x. The equation ax square plus bx plus c is equal to 0 is called general or standard form of quadratic equation. The highest index of variable is 2. So, it is a second degree equation in one variable. Do you know? In the quadratic equation, ax square plus bx plus c is equal to 0, the constants a, b and c are called the quadratic coefficient, linear coefficient and constant term or free term respectively. The term quadratic comes from the quadratus, which is a Latin word for square. Look at these equations. Are the equations quadratic? How do we decide? 5x square is equal to 36. Y square minus 5y plus 4 is equal to 0. 5m cube minus 4m plus 7 is equal to 0. 5z minus 7 is equal to 0. Compare these equations with general form of the quadratic equation. 5x square is equal to 36. Here, a is equal to 5, b is equal to 0, c is equal to minus 36 are real numbers where a is not equal to 0. It is a quadratic equation in variable x. y square minus 5y plus 4 is equal to 0. Here, a is equal to 1, b is equal to minus 5, c is equal to 4 are real numbers where a is not equal to 0. It is a quadratic equation in variable y. 5m cube minus 4m plus 7 is equal to 0. Here, maximum index of the variable m is 3, so it is not a quadratic equation. 5z minus 7 is equal to 0. That is 0 into z square plus 5z minus 7 is equal to 0. Here, a is equal to 0. Therefore, it is not a quadratic equation. It is a linear equation in variable z. Let us solve exercise 2.1. Question 1. Which of the following are quadratic equations? Number 1. 11 is equal to minus 4x square minus x cube. Solution. 11 plus 4x square plus x cube is equal to 0. That is, x cube plus 4x square plus 11 is equal to 0. Here, maximum index of the variable x is 3. So, it is not a quadratic equation. Number 2. 3 upon y minus 4 is equal to y. Solution. Multiplying both sides by y, we get 3 minus 4y is equal to y square. That is, minus y square minus 4y plus 3 is equal to 0. That is, y square plus 4y minus 3 is equal to 0. Here, a is equal to 1, b is equal to 4, c is equal to minus 3. So, it is a quadratic equation in variable y. Number 3. n minus 3 is equal to 4n. Solution. Minus 4n plus n minus 3 is equal to 0. That is, 4n minus n plus 3 is equal to 0. That is, 3n plus 3 is equal to 0. That is, n plus 1 is equal to 0. That is, 0n square plus n plus 1 is equal to 0. Here, a is equal to 0. Therefore, it is not a quadratic equation. It is a linear equation in variable n. Number 4. Z minus 7 upon z is equal to 4z plus 5. Solution. Multiplying both sides by z, we get z square minus 7 is equal to 4z square plus 5z. That is, z square minus 4z square minus 5z minus 7 is equal to 0. That is, minus 3z square minus 5z minus 7 is equal to 0. That is, 3z square plus 5z plus 7 is equal to 0. Here, a is equal to 3, b is equal to 5, c is equal to 7 are real numbers where a is not equal to 0. It is a quadratic equation in variable z. Number 5. 3y square minus 7 is equal to root 3y. Solution. 3y square minus root 3y minus 7 is equal to 0. Here, a is equal to 3, b is equal to minus root 3, c is equal to minus 7 are real numbers, where a is not equal to 0. It is a quadratic equation in variable y. Question 2. Write the following quadratic equations in standard form: ax square plus bx plus c is equal to 0. Number 1. 7 minus 4x minus x square is equal to 0. Solution. The quadratic equation can be written as follows in standard form: ax square plus bx plus c is equal to 0. That is, minus x square minus 4x plus 7 is equal to 0. That is, x square plus 4x minus 7 is equal to 0. So, x square plus 4x minus 7 is equal to 0 is the standard form of the given quadratic equation. Number 2. Into brackets m plus 4 into bracket m minus 10 is equal to 0. Solution. The quadratic equation can be written as follows in standard form: ax square plus bx plus c is equal to 0. That is, m square minus 10m plus 4m minus 40 is equal to 0 on opening the brackets. That is, m square minus 6m minus 40 is equal to 0. So, m square minus 6m minus 40 equals to 0 is the standard form of the given quadratic equation. Number 3. n minus 7 upon n is equal to 4. Solution. The quadratic equation can be written as follows in standard form: ax square plus bx plus c is equal to 0. Multiplying both sides by n, we get n square minus 7 is equal to 4n. That is, n square minus 4n minus 7 is equal to 0. So, n square minus 4n minus 7 is equal to 0 is the standard form of the given quadratic equation. Number 4. X square is equal to minus 7 minus root 10x. Solution. The quadratic equation can be written as follows in standard form: ax square plus bx plus c is equal to 0. X square plus root 10x plus 7 is equal to 0. So, x square plus 7 plus root 10x is equal to 0 is the standard form of the given quadratic equation. Number 5. M square plus 5 the whole upon m square is equal to minus 3. Solution. The quadratic equation can be written as follows in standard form: ax square plus bx plus c is equal to 0. Multiplying both sides by m square, we get m square plus 5 is equal to minus 3m square. That is, 4m square plus 5 is equal to 0. That is, 4m square plus 0 into m plus 5 is equal to 0. So, 4m square plus 0 into m plus 5 is equal to 0 is the standard form of the given quadratic equation.